Welcome. Multiple linear regression using R, what we are going to discuss today. I shall do all these things using R from Introduction to Econometrics, Stock and Watson, Chapter 4, 5, 6 and 7. In the previous video, I have done it using Stata. So I have already shared these files and I will share these files again. So you can see this chapter 4 code, chapter 5 code, chapter 6 code, chapter 7 code. So you can see all these files I have shared and I will share it again in the link from Google Drive. Okay, be with me. Let's go. And first of all, we run library tidyverse. Library tidyverse contains many packages, ggplot, dployer and all those packages. Those who are not familiar with R, they can learn some basics and then they can do. I have some videos on learning R and all that. So library read Excel, I am doing it because I have to read data from Stock and Watson, which is in Excel form. So here I have given the address where my data, the data drive where my data is present. So I have now California school data. Now if we want to take summary of California school data, which we have been discussing time and again, that is here. Okay. Summary of student teacher ratio. So minimum class size is 14, maximum class size is K 25.8, which is bit odd. It should be a whole number, but maybe some averages. So now we are going to plot this ggplot. Here we give data name, aesthetic, student teacher ratio, test score on y-axis. Since it's a scatter plot, so geom plot, and I am limiting y from 600 to 730 because we know minimum value is 600, maximum value is 706. So we cover it from minimum to, and I give plus gg plot, gg title. So here you have a plot. And now you can see this plot, and what we have been discussing throughout this course and the videos I have uploaded on linear regression with one regressor, with multiple regressor, testing of hypothesis. You can watch those videos from there. Now if we want to add a regression line, so what can we do? We can add geom smooth. Method is linear regression and standard error false. If you don't do standard error false, it will give you 95% confidence interval along with it. So now you have this line fitted, and if I remove this standard error false, you have here this 95% confidence interval is also associated. So Control Z. Okay. Now we are going to regress test score on student teacher ratio, and instead of the command is LM, linear modeling. Data is California school data. Library modern dive is very useful one to get regression tables in a nice form, but if you don't use, even then it doesn't matter. I get this get regression tables. Now I have intercept, I have student teacher ratio and all that. And or the other way around is you can do this, use this parenthesis and you will get this result. Another way is run this one and you will get this one. And if we take the summary of test score model, it will look like this way, and you can see this whole summary in this table. We have this estimate, standard errors 0.47 and R square and adjusted R square, all that. That's not what we are going to discuss here. This we have discussed conceptually in our videos. Now if you go to chapter 5, so we have a get regression table, the same thing. Which we have discussed already. And if you want to find out what is critical value with 418 degree of freedom, so you have minus 1.9656, and you can use also heteroscedastic corrected standard errors, library LM test, library sandwich, and now you see Okay, in this case your standard error is 0.51, whereas previously it was 0.47. So this is heteroscedastic corrected standard errors. Whether our residuals follow standard normal are random or not, so the test is that we have summary, we get residuals u, and we make a GG plot, and you see, if you look at this, so our residuals seem, this is mean 0 and seems quite random. So you can have formal tests, but this seems okay. So now we go to create a variable using dplyr, California school data. This is pipe operator, mutate. You are calculating a new variable, which will be that if student teacher ratio is greater than or equal to 20, it's 1, otherwise 0. That we have done in stata as well. So you can run a binary regression. We have selected here variables. It's up to you whether you want to select a set of variables or you want to keep on working with whole data. It will not make much difference here because data sets are not very large in size. But if data sets are very, very large, then you can select only relevant variables like Pakistan, like demographic health survey data sets, like labor force survey data sets, or some other very large data sets. So you have regression dummy variable here, coefficient, again variance covariance matrix, and you can go ahead. Now you have regression table where only student teacher ratio is included, student teacher ratio plus English learner percentage. So we are regressing test score on 2 variables, and I am going to make here a very useful table using Stargazer library. So library Stargazer, and your results will look in a okay, this will be a very nice output as I have shown you here in chapter 7. Look here. So you can have these variables in this form, results in this form. This I have also constructed in stata in my previous video. Okay, now if we go to chapter 7, we have already discussed that there is restricted model, unrestricted model. We have regressed test score on student teacher ratio, English learner percentage, expenditure per student. This is unrestricted model. And then we have imposed 2 restrictions on student teacher ratio and expenditure per student. Okay, I have slightly different restriction, and now you have a restricted model residuals, you have unrestricted model residuals, or you can say that you have an analysis of variance. You have on student teacher ratio and English learner percentage and expenditure per student. The F statistics comes out to be 142.27, so we reject the null hypothesis, and it means restriction do not hold. So you can go with this summary of regression tables and Stargazer. Again, I have now 5 models. Model 1 where we have only student teacher ratio. Model 2 where we have English learner percentage added. Model 3 where we have meal percentage added. Model 4 where we have used income assistance in place of meal lunch at school. So these 2 can be considered as proxy for income level. So, and in the final model we have included both of them, and then again we have used Stargazer library, that's 8. And if you see these results are exactly the same which we have discussed. Chapter 7 last pages there is a table, and you can verify these results. Thank you for being with me, and I will upload all the links under this video where you have all these codes in more nice way than probably what I have discussed in this video. Thank you for watching. Take care.